Hello everyone. Welcome to the video on solving linear equations using Cramer's rule. In this video, we would be covering the following topics. Number 1. Steps to be followed for solving linear equations using Cramer's rule, and number 2. Example for solving linear equations in two variables by Cramer's rule method. Let's get started. While solving linear equations using Cramer's rule, the first step is to write both the given linear equations one below the other. Next, ensure that both the linear equations are in the form ax plus by equals c. Now, hide the constants in both equations. You would now see the x term and the y term in both equations. Form a matrix comprising of the coefficients of the variables. Name this determinant as d. Now, hide the coefficients of first variable, that is, x term, in both equations. Form a determinant comprising of the coefficients of the constant and the second variable. Name this determinant as dx. Note that the column containing constants should be first followed by the column containing coefficients of second variable. Next, hide the coefficients of second variable, that is y, in both the equations. Form a determinant comprising of the coefficients of the first variable, that is x, and the constant. Name the determinant as dy. Note that the column containing coefficients of first variable x should be first followed by the column containing constants. Evaluate values of determinants d, dx, and dy. Find out the values of x and y using the relations x equals dx upon d and y equals dy upon d. Hence, x, y is the solution of the given linear equations. Let's now understand this with the help of an example. The given equations are y plus 2x minus 19 equals 0 and 2x minus 3y plus 3 equals 0. First step is to write down the two equations as it is. Next, we have to ensure that the two equations are in the form ax plus by equals c. Thus, we have 2x plus y equals 19 and 2x minus 3y equals minus 3. Here, the first variable is x and the second variable is y. Now, hide the constant terms. Enter the columns of x and y coefficients in a matrix. Thus, we get 2 in first column and 1, minus 3 in second column. The value of this determinant is equal to d. To calculate dx, hide the coefficients of x. You would now see the coefficients of y and the constant terms. Enter these columns in a matrix. Note that as we are hiding the first variable x, the constant term column should be entered in first column and then the coefficients of y in second column. Thus, we get 19, minus 3 in first column and 1, minus 3 in second column. Now, to calculate dy, hide the coefficients of y. You would now see the coefficients of x and the constant terms. Enter these columns in a matrix. Note that as we are hiding the second variable y, the coefficients of x should be entered in first column and then the constant terms in second column. Thus, we get 2 in first column and 19, minus 3 in second column. Now that we have obtained the matrices d, dx, dy, we have to calculate their values. Value of a determinant a, b, c, d is calculated by a into d minus b into c. Thus, we have d equals 2 into minus 3 minus 2 into 1 equals minus 8. dx equals 19 into minus 3, minus 3 into 1 equals minus 54. dy equals 2 into minus 3, minus 2 into 19 equals minus 44. By Cramer's rule, the value of x equals dx upon d equals minus 54 divided by minus 8 equals 27 by 4. The value of y equals dy upon d equals minus 44 divided by minus 8 equals 11 by 2. Hence, the solution to the given pair of linear equations is represented by x, y, which is 27 by 4, 11 by 2. With this we come to an end to the video on Cramer's rule. Thanks for watching. Hope you liked it. For more content, Please subscribe to our YouTube channel and visit our website aptitudequestions.net.